Well, hello, class. This is Miss Bourne, and I've heard that there's some discrepancy between what's an independent event and what's a dependent event, and when do we need to figure this out in life with probability, and when do we need to add fractions together, and when do we need to multiply, when do we need to decrease our denominator, and so those are the things that we're going to discuss today. Join with me in the library.
Alright, okay. So today we're going to talk about dependent and independent probability. And basically, independent probability means that no matter what is happening, you have the same chance, you have the same number of things to choose from. Okay, so it just means that the event is not affected by anything else. Dependent probability, that's what that's saying is something is changing. So you're going to pick something and then you're going to have something else to work with. And this is just a bunch of mumbo jumbo, so I'll show you what I'm talking about. So right here, we have this beautiful series by Stephenie Meyer, okay, Twilight series. We have 3 new moons, 1 twilight, 3 eclipse, and 5 breaking dawns, okay? So let's just talk just about independent events for a second. What is the probability of me picking breaking dawn? Okay, well there's 5 out of the 12 total. Okay, so 5 out of 12. So the probability of picking breaking dawn is 5 out of 12. What's the probability though of me picking breaking dawn and then eclipse? Okay, well, first time, this is independent. So let's just say I do this. Probability of breaking dawn is 5 out of 12. I just picked this up. But I want to replace it. I'm going to put it back because this is an independent event. So that means I picked it. It's 5 out of 12. Now what's happening? I want to pick the eclipse. But that's 3 out of 12, okay? Still have 12 to choose from because I replaced it. So when you have 3 out of 12 and 5 out of 12, then you'll multiply them together, okay? You can simplify and you can make 3 out of 12 1/4. I'm not going to go ahead and multiply those out for you right now because I don't have any paper. I'm not going to keep getting up. But let's just say you have 15 out of 144, okay? And you could just, you could simplify both those by 3 and you could get 5 out of 48. 5 out of 48. Okay, so anyways, that's independent events. It's super easy, okay? So independent events, you just take what you want. Breaking dawn, 5 out of 12, times eclipse, 3 out of 12, okay? That's all. Here's where it gets tricky. The probability of dependent events. So if I said, what's the probability of me picking up, let's try something else, twilight, and not replacing it, keeping it, checking it out at the library, and then coming back later and picking out new moon, okay? So it's a dependent thing. So first I've got the probability of picking twilight. 1 out of the 12 total options, okay? Now I'm coming back to the library the next day. I've already got my twilight book. Well, I really wanted new moon. So what's the probability of this event? Well, there's 3 new moons out of how many total? Not 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I had a 1 out of 12 chance to pick this up on the first shot. And I didn't return it. So I had a 3 out of 9. Whoa, 11. 3 out of 11 shot, okay? 3 out of 11. So 1 out of 12 times 3 out of 11. So that's the thing with dependent, is your total choices, they decrease. Dependent, decrease. Okay, so what about this? This is a harder one. What is the chance, okay, so I pick out an eclipse book, dependent events. Pick out an eclipse book, 1 out of 12, 3 out of 12, okay, or 1/4. So I picked out an eclipse book. I'm not returning it. What's the chance that I'm going to pick out an eclipse book again? Well, don't forget, you already picked out 1 eclipse book, so this is a good one. So dependent events decrease, so we have 11 total choices, but it's not 3 anymore, it's 2, because you already picked that book, okay? So you have 2 over 11. So you have 3 over 12 as your first one, as the probability of getting eclipse on the first shot, and then times 2 over 11 for the probability of getting it on the second shot. Okay, now a question that has nothing to do with dependent or independent probability, just probability in general. Out of these 12 books, what's the chance that you're actually going to get a good book? 0 out of 12. 0%. Harry Potter, Hunger Games, baby.